Hello everyone, welcome to another session. This is Suresh. So in this session we will look into the lab. In this lab we will start with identifying damaged car parts with Vertex AI for AutoML vision users in the Google Cloud platform. So without any further delay, let me start the lab. And in this lab, our objective is to complete the tasks provided here, and we will not uh, discuss anything theoretical or technical. So we'll just go to the way it is. Okay. I hope this view is looks good. Let me copy the password as well. So we'll not completely use the 1.5 hours. So we will soon complete as soon as possible. So as we are not going to discuss anything theoretical or technical here, we will directly go with the flow. So at any point in time, you can pause the video and go through the overview. So this overview gives about the AutoML, Vertex AI, and those things. And in the learning objectives, this is the learning what we are planning. So, so unlabeled, upload the label dataset in Google Store using CSV Fly and connect it with Vertex UI as a managed dataset. Inspect the uploaded images to ensure there are no errors in the dataset. Review a train model and evaluate the accuracy. So we just now completed the task 0. So let's see whether we have completed everything. So we have connection, password, navigation menu, everything. So let's activate the Cloud Shell as well. So you on top right you can see Cloud Shell. So let's activate it as well. So it will take a couple of seconds to activate. So let me open it in a new window here. So we will have a better view. Okay. So let's authorize it first. So the user student is authorized and also configure the project. The project is also configured. Okay. Now upload the training images to cloud storage. You can pause the video. So you can see there are 5 different damaged car parts: bumper, engine compartment, hood, lateral, and windshield. So first we will in the cloud shell. So let's create a, first we'll define that project ID and the bucket name. And in the second, we are creating the budget in Europe West 4 inside the project ID. So this is GS util make bucket in the project, in the standard, the Europe West 4, and the bucket name. So bucket is getting created. You can cross check that here in the Google console as well. So let me open it in a new link, and you can see bucket is created with the project name. So similarly, we will copy the all the files that is available in the public storage called car damage lab images into this bucket. So content is getting copied. So let's wait for a few more seconds. Oh, now here this is what the save we are showing us. The buckets, let's click on it, and you can see the bumper, engine compartment, all other folders here or buckets. So let's check the progress. So let me select the bumper, and we have some JPGs over there. We have 21 JPGs. That's fine. Now let's create a data set. The cloud shall create a copy of the file, execute the following command. Okay. Let's see the files. An optional. Yes. You can see data.csv file is created or copied from. So now let's update it. Execute the following command. SCD damages bucket. So let's verify the bucket. So we have some text here. So uploading the file as well. And we can go and double check here the quick labs folder. So let's go back one step back, and we can see data.csv has been uploaded. Now create a managed dataset. So let's navigate to Vertex AI dashboard. Select enable all recommended APIs. Here you can see the datasets. Now create dataset. And let's name the dataset as they have provided managed parts. And image classification. The image classification, single label classification. Okay. Now let's select the region as 0 pest 4. Click on create. So I'm waiting for that data set to get completed. Now select the import method section and select import from cloud storage. So I'm just waiting for the dataset. So I'll pause the video for a few seconds. So it took me about 7 to 8 minutes to get this dataset as ready. So let's click on this and start importing these steps from the side. Okay. Select import from the cloud storage. Browse. Select the file. And we have this green tick. Click on continue. Import in progress. So this is going to take several minutes for me. So if you see, it will take about 9 to 12 minutes for your images to import and to be aligned with the category. You need to wait till the step is complete. So what I will do is I will pause the video and can continue. So It took about, as they mentioned, 9 to 12 minutes. It took about more than 12 minutes for me to get this images ready. So now the status is ready. So let's browse as an optional step. So you can see there are 100 labeled, 0 unlabeled, training is 65. So this is the split we have. So you can see some sample images. So in all the categories like bumper, hood, windshield, everything is having 20 pictures. So let's check the progress of task 3. This is what we just did. If your browser is refreshed, click on this. Okay, filter label. Okay, need images to ensure high accuracy. This is just a 20 images for each type. Okay, this is a note to consider. If an image is labeled incorrectly, you can click on it, select. Okay, let me get inside this data set. We can see the images and we can see. So let's click on analyze. You can see all the categories as having. My question is, now everything is labeled, but we have an option to change the. If we select windshield, if this is not a windshield, then we can change this to hood. So that is the change we can do. Okay. Now in the right side, we can see train new model. So let's click on train new model. And the training method, leave the default configuration, select the AutoML and click on continue. The model details, use parts model, click on continue. Computer pricing, set your budget to 8. Okay. Eight node hours. So start train. Estimated completion hours is 1 hour. You might have seen that. But here in the note, what they mentioned is like model training may take longer than allocated time to complete the lab. The model does not need to finish training to continue the next section. So let's click on the progress. Now request a prediction. You can pause the video and go through the text what they are saying about what this lab about. Request a prediction from hosted label. In Google Cloud Console, navigate to Cloud Run. This is the navigation and navigating to Cloud Run. In the Cloud Run, we can see AutoML proxy. Okay. I think they have already created this for us. Okay, copied the URL as I mentioned. Open a new Cloud Shell window. Let me duplicate this Cloud Shell. On the edit. Let me go back to this and let me activate it directly from here. Now here I can see the open editor. Okay, click on File, New File. Again, repeating the same steps. Selecting the text file, pasting the code. Let me copy this code, paste it over here. After why there is an error, or so let me save this file, save as hello.json form. Okay. I don't know just what happened here. Okay. Okay. For reference, use a base64 string from the following image. Next, the content you supplied is base64 string. Okay, this is the content. Okay, correct. Fine. Now, let's set the following environment to copy into the proxy to retrieve earlier. Okay. Okay, where should I update this? We have content threshold maximum. Okay. Perform API request proxy endpoint to request the prediction. Okay, we can request this. Okay, let me take another file just for our purpose. It's the text file. I'll paste it over here, and in the dashboard, in the Cloud Run, we have that URL. So let me go on the Cloud Run, open the AutoML proxy, copy this, paste it over here. Okay. So the terminal. Okay. Now let's perform this request. So predictions bumper for confidences. Confidence is 95.15, ID deployed model, and we have this information. So this is looking good. Again, let me repeat that step. So 95.15 confidence, so same. Display name is bumper, correct, and prediction, and it's respect to ID in the model. So this gives a good info. Now let's check the progress. Okay, let's follow this. Let me copy save this image as image one. Let me save this image as image two. Cross check. Let's try to open both images. Okay, this is image two. Looks good. This is image one. Looking good. Now open the base image encoder. Use a file. You can download image one. One open or copy the base64 equivalent. Encode a string in the content field in your JSON payload. So this is what we copied. Looks good. Let's get into the Word editor. Content field. Yeah, just paste it the latest updated code. Now let's save. Go back to the terminal and execute the same piece of line. And previously it was a bumper. Now you can see it is a car engine compartment, and the confidence is 98.54. This is good. Now let's take another image. Let's take image 2 this time. I'm not sure whether this is re-uploaded already because I see the same content code here, but let's try again the editor. Do this first. Paste the base and control yes. Let's take the terminal. Let's try this. This is good. Looks perfect. So, and the confidence is 96. So this is how the API is getting predicted. The model is getting predicted. Replace the base 64. This is what we just did. And how did it perfect 3 images correctly? You should see the following over. One is engine compartment. Previously we saw, and the second one is foot. Yeah, this clears. This is the end of this session. So thanks for joining me and have a great day.